Hi, I'm Katie. Thanks so much for joining us. This is the Introduction to Data Visualization with Python for New York City Open Data Week. This workshop is offered by the Barnard Vagelos Computational Science Center in collaboration with the New York City Open Data Week. It doesn't require any previous coding experience, but learning to code takes time. And it's okay if not everything in this workshop clicks right away. We just hope that you can follow along, get familiar with the experience of coding and the topics that are introduced, and have the opportunity to explore New York City open data first. So the beginning part of this workshop will be an introduction to Python fundamentals that are expressly useful for this workshop. There are lots more to learn in Python, and if you're looking for a comprehensive introduction, we recommend you, after this workshop, if you're excited, explore the myriad Python resources available online. For this workshop, you don't have to have Python downloaded to your computer. You don't need an IDE downloaded to your computer, which is the space in which you code, because we're going to be using Google Collaboratory, which is an online cloud-based coding environment. So I'm going to share the link with you to find Google Colab right now in the chat. And there it is. And I will also share a key. I didn't realize how many people were going to sign up for this workshop, so I didn't have a professional key available, but now that there's so many people and I'm worried about chats, I'm going to I threw together a key. And if you get lost, if you want to not be as engaged at the workshop and like actively engaged, you can use this key, which I will put the link in. It's also hosted in Collaboratory Notebook here. So Python notebooks are shareable, and this is why you're able to have all the code available in this Collaboratory notebook. I recommend you start with the blank notebook with me and follow along so you can actively learn how to code. If you get lost, this key is available for you. Okay, so this is what Google Collaboratory Notebook looks like. And it's, as I said before, it's located in the cloud, so it's web-based and it's in your browser and you don't have to have Python locally. This is the entry Google Colab. We want to make a new one. So we'll click File, New Notebook, and we'll get a blank notebook. So this is basically the space in which your code can run. And we'll be coding in Python. It's a really versatile language, super flexible, and you can pretty much use it after this workshop towards anything you're interested in. So with this Google Colab, what you see here is a text cell, and a coding cell, and we can write our first line of code in. So we can write print, parentheses, and then you want to put quotation marks and type in hello. When you press play, it will load, and it ran, and now we see the output hello. And it printed out what we told it to, just a command. And let's write. We can add in more text cells in Google Colab by clicking this plus code button. Let's add in a couple. So let's go to the next code line, and we're just going to go over some Python basics to start before diving into graphing and visualizing data. So what is this thing inside the quotation marks? It's called a string. And in Python notebooks, if you type in a string, the very last thing of value in a cell will automatically print out. So if we press play, we'll see that the last thing of value printed. There are other things in strings. We can have numbers like the number 5, and it'll return 5. And we can also assign these values to variables. So let's first write our string, and we'll say this is a string called hi. And we know it's a string because it's encapsulated in quotation marks. We can assign this, so we're going to put it in something, so it gets put into a variable, and we can call it whatever we want. I'm going to call it hi. So hi equals this, and equals doesn't mean equivalence, it means assignment in coding. So this string called hi is getting put in hi, and then we'll just write hi underneath so that it prints out. So we press run, and hi printed out, and it printed out the value stored in it. This is a string called hi. So there are other kinds of values. As I showed you, there's this number 5, which is called an integer. It's a counting number, and you can have numbers with decimal points, floating point numbers. So we can just put whatever we want, 5.82, whatever, and press play, And whatever that does, the number is returned to you, and it's in a form called float. We can add some more coding cells, and let's get into what are called arithmetic operations. What is this thing with the hashtag in front of it? When I press play, nothing happens. This is a comment. I'm able to write notes to myself. It's just a place that the compiler is not going to execute this line of code. It's just for us to be able to talk to ourselves or talk to somebody else reading our code. So we're about to learn arithmetic operations. So we can do things like 5 plus 5, and it'll return 10. We can do a series with if we want to do a couple arithmetic operations in a row and see them all get printed out, we'll use this print that we said up here, we said hello with. So inside those parentheses, print parentheses, let's do 5 times 5 with the star. Let's print parentheses 5 to the power of 5, which is 2 stars. We can print 5 divided by 2, and we can print what we'll see in a second, 5, the divided sign twice, 2. And when we press run, we'll have all of these operations have run. What we see here is we have, I'll just write little notes. You can follow along if you want this to be notes for yourself. So this is multiply, this is exponent, so like to the power of. We have division, 2.5, because 5 divided by 2 is 2.5. And then we have this one, 5 divided by 2. And this is, if you notice, the 0.5 is just gone. And it's kind of rounding down. It's called floor division. But let's use some of those variables we learned about where we put values into variable. A is going to be our variable name, assigned equals, quotation mark, hello. B equals, quotation marks, world. And A plus B. You can't add strings. They're not numbers, but what happens when we press? So in Python, we'll see that it's very flexible. And so with different types of variables, different things will happen. So here we'll see that we have hello and world got placed into one string. And we'll notice that there's no space between hello and world. That's because the computer doesn't know what you want it to do. It only knows exactly what you tell it to do. So we can go in front of world and place a space, and we run it again, and now we'll have hello world. So now let's go into equivalence. So we see how assignment happened with the 1 equal sign. So how do we show if something's equal? So I'm going to write in a comment, equivalence. So we can print, so we can see what happens. 5 equals 5. So they just use equal signs twice. And what do you think this is going to return? You press play, and it returns true. It's a true or false statement. If something equals something, it's either true or it's false. So we can have numbers equal each other. What if we have print 5 equals the string version of 5? So in strings, you can either have single or double quotes. It doesn't matter as long as you're consistent. So print 5 equals 5, and it's false because they're different types. Just like how we saw Python does the plus with strings, concatenates them. If it was numbers, it adds them. They're different things, even though they look to us the same. So what if I want to say that things don't equal each other? We can print 5 does not equal 5. And so the explanation point equals is does not equals. And we can print 5 does not equal the string version of 5. And when we run that, we'll see that our booleans our true falses have flipped. So now the first one is false and the second one is true. So what if we want to have if we want to do multiple things in a row and we have these print statements and we want to reuse some of the code so we don't have to write it every time. There's this thing called a function, and a function's a lot like this is a version of it where we have a command and it does things for us. So let's write our first function. So hashtag function. To write a function, we need to define it first. So we'll use this keyword called define, and let's write a function that adds 1 to a number. So let's name it plus underscore 1, And then we'll place these parentheses and a colon. Then underneath, we will write return 1. And this isn't going to do what we want it to do yet, but let's see what happens when we press play. Okay, it compiled, that's great. And when I say compiled, no errors were thrown. Say I come over here and I delete this space and I press play. I'm gonna have this error and it says expected an indent block. And that's because Python's very particular about its white space, which is just spaces that you see on the screen. So let's click before the return and place a space in. Another error that could happen, it would be if you come in front of, let's see what happens with the white space if we place a tab here. Again, unexpected indent. So we need to make sure if you're having issues coding, they're just reading these errors exactly the compute and just try to fix them. So here we go. We have def plus 1 return 1. Now underneath, let's see what happens if we call this function. So plus underscore 1 parentheses, press play, and we return 1. So this value, this function has now gotten this value 1, a lot like our variables. So how are we going to use a function just to add 1 to a number? We need to have a variable that goes into this function, and we pass it in as a parameter, is what it's called, inside this method. So let's call it number. And this is like saying we have a variable, and we're going to return number, which is our variable, plus 1. Now if we press play, we get another error, and it says missing one required positional argument number. So inside plus 1, we're going to place a number. We can assign it just like a variable, number equals 5, and we press play, and now we get return 6. We can also, because there's only one argument, you'll often see they don't actually explicitly say a number assigned to 5. It will be inferred, and we can just write plus 1, 5. Here we go. So why is this useful? So now we can have plus 1. Let's print out print plus 1, and we can place the number 89. Now underneath it, let's write print plus 1 parentheses 33. And let's do an x equals 800. So we've assigned 800 to x. Print plus underscore 1 x. And when we press play, we'll see that we've added 1 to all of those numbers. So in this instance, yeah, adding 1's not such a big deal, but you could have a lot of code happening and you get to reuse it and change it based off the parameters you get to put in. So that's why functions are really powerful. And we'll see them a lot when we're graphing because we're going to be using another library's function, so we don't have to code it. Let's go into a couple data structures, or what are called loops. And don't worry so much about them, but it's good to be exposed to them just so that you know a little bit more about how coding can be used. So first we write a underscore list equals, and we're going to have a list of values. For a list, you define it with these square brackets. Inside our list, we'll put in a couple numbers, 3, 10, 500, and you separate what you put into your list with commas. So we can print a underscore list, and we'll get the same, we'll get it back. We can also do things like writing len around it. So just like our print statement printed, the len will tell us the length of our list, and the length is 3. It has 3 values. The other thing is you don't have to have just one type in. You could have whatever you want. You could have strings and numbers and all sorts of things and inside your lists. I'm going to change it back to a number and add some more code boxes. If we wanted to go through our list, we can iterate through it with what is called a for loop. So we're just going to go through each thing inside our list. So for something in a underscore list, colon, and just like when we wrote our function, that white space between right here is quite important. Print, and let's just print I. And now it went through and it printed each thing inside our list. We can also apply things to it. We can say print I times 2, or we can even say print our underscore 1 function we wrote on I. And so now you see each item has used this function we wrote before. So I is just a placeholder. It can be called anything you want as long as you're consistent. So just to show you that, we can say for thingy, like nothing more less technical than the word thingy, in a underscore list colon print I. And oops, we're not printing I. This is exactly, we want to, again, it's that consistency. So here we had I, and here we have thingy and I, and so it didn't actually work. We have to have thingy and thingy, just consistency. It doesn't matter what it is as long as it's consistent. So that's a little bit about lists. We can also grab things inside of our list. In computer science, often counting starts at 0. So if we want to get the very first thing inside our list, so a underscore list, we can use these square brackets and say I want the 0th thing. If we print that, we'll get the first element in the list, which is 3. Similarly, if we want the last thing in a list, a underscore list, we don't want the third element because it doesn't exist. We want the last element minus 1. So that would be the second element. And that would be the final thing, which is 400. So the last thing we'll do for our intro to Python basics is we'll introduce you to something called a dictionary. And it's a lot like a list, except for it's unordered and it has key and value pairs. First, let's just give us a variable we can hold it in. So a underscore dictionary equals, and list had square brackets, a dictionary has swirly brackets, which might be hard to find if you're looking for it for your first time, but find the swirly bracket braces, and then we'll have a key and value pair. So for instance, we'll have red, colon, and then parentheses, quotes, balloon. And we're saying the red is associated with balloons. They're mapped together, comma, and we can have another key value pair. And we'll say brown is the key, and dog is the value pair. So red is to balloon, brown is to dog. So if we let's write a underscore dictionary, and we can print it out, and we'll see that it looks just like what we wrote. So now that it's unordered and there's not an index like a 0th or first or second element, how do we get the stuff inside this dictionary? How do we access it? And yeah, we don't have a number, but we do have these keys. So if we write a underscore dictionary, square brackets, and we put in the word brown, which is the key, and we press play, we'll get returned the value dog. And so you can see how this might be really powerful, how you can map things together. There's other things you can do with dictionaries that I'll just show you really quickly, which is a underscore dictionary dot keys, and you can get all of the keys, red and brown, or you can have a underscore dictionary dot values, and you can be returned all the values. So now that we have a little bit of an introduction to Python and some of the basic functionality, let's start talking about data visualization. So what are data visualizations used for? They're used for so many purposes and in so many fields, but primarily they're used to communicate an argument, for you even to be able to figure out what's happening in data. It's a tool of communication. And this is important because we have lots and lots of data. If we just had a list of data, we can't discover patterns. We can, just by looking at thousands of numbers, we need to be able to figure out what's happening, and this is what data visualizations are really useful for. You'll see the New York City Open Data Week that it's used in. Data visualizations are used in fashion, they're used by the government, and so no matter what you end up doing after this workshop, playing with a little bit of data visualizations can be used. For data visualizations, we are going to use a library called Altair. And when we use a library, it's like saying, I want some extra tools. I don't have enough. I don't want to make all the tools myself. I can go and call this library and say, I want to use your stuff. So let's import some tools that will help us to create our data visualizations. And the tool we are using is Altair. So we import it into our notebook, which is us getting our tools and bringing it to our notebook. And we will give it a nickname, so we don't have to write Altair every time we want to use our library. And we'll say as ALT, so as alt. And this is like a nickname or an alias. Oops. And the other library we want to import is Pandas. And Pandas is going to help us work with something that's called a data frame. And it's basically just a table of our data and will help us to just change it and have the abilities that would be very difficult without Pandas. So import Pandas as PD, and we press run. Nothing happened, like you don't see anything happen, but it grabbed our tools and brought it to our notebook. If you get an error later in the next part of the workshop that says, oh, Pandas not found, it means that you need to come back and press play on this button. So let's add some more code boxes. We will be using JSON data in this workshop, and this is why talking about dictionaries was really important, because JSON data looks a lot like a dictionary. So let's write our own data to work with first before getting some data that's out in the wild. So people_dictionary equals swirly brackets, just like we had before. Inside our swirly brackets, we're going to have our key and value pairs. So our first key, let's do so it's a dictionary of people. So we want to have maybe name is an important column to have. So that's our key. And our value is going to be a list, because we want to have a lot of things in our table. We don't just want to have one value. So we'll have a list, which is those square brackets, of some names. We'll put the names as strings. I'm going to have a Susan, going to have a Mark, a Sienna, maybe a John. And then we'll have a comma, because that's our key value pair for the first one. And let's have our second key value pair, which is like another column in our data table we'll have. And we'll have it be age. People, as in everyone has an age. And again, it'll be a list, because we need every single person we've listed to have an age. For Susan, we can make her 20, Mark can be 30, Sienna can be 2, John can be 40. You can make these numbers anything you want, and the names anything you like. Just make sure that there's the same number of entries on both the name and the age. So here you see 4 and there you see 4. You press run and we're good. So now underneath here, let's convert this dictionary to the data frame thing that I talked about. So to do that, we're going to use Pandas, because as I said, Pandas is going to help us work with our data tables. So PD, which is the alias for Panda. So we're saying I want that library dot, and let's use this data frame method, parentheses. And just like when we pass in the thing, we passed in a number to get added 1 to, we're going to pass in the data that we want to turn into a data frame. And that is our people dictionary. So people_dictionary, and press play. And when you press play, a table pops up and you see a column for names, a column of ages, and these 0, 1, 2, 3 indexes, which is each row has been assigned an index number. So what would have happened if we had a missing age? So we only had 3 ages. So I'm going to press play again. It's reassigning this new dictionary to people dictionary. And I press play and I get an error. They have to be the same length. And it makes a lot of sense when looking at it, because it's each entry needs to have a number or have a value. So now let's plot this data, and this is when we would use Altair. However, one of the reasons why we're having an Altair workshop is because there's another way of plotting called Matplotlib, and it's quite confusing. It gets really convoluted. It's pretty notorious, but it's also an important thing to know. So we're going to show one plot with Matplotlib, and then we'll go into Altair. So to print out a Matplotlib plotting with either the Pandas or Matplotlib, we need to put this %sign and write Matplotlib in line. And that's just letting it so we can see it in our notebook, or else it plots wouldn't show. We press play, and then we will take we need to get our values as this dictionary as our data frame. And we don't have it yet because we didn't assign it to a variable. So we need to assign this first to a variable so we can use it when we're plotting. So let's name this people_df, and this will hold our data frame that we can use with Matplotlib. So now we'll go down and we'll write people underscore df. So this is our data frame dot plot. Seems pretty, like English. I want to plot it. Dot bar. So we're going to make a bar graph. Parentheses. And in the parentheses, we are going to say what we want our x and our y axes to be. So we'll say x. We're just passing in what we want our x and y axis to be. So x equals, so it's just like when we had number equals 1. So x equals, and we're going to want it to be a column. So if we, just to show you again what our columns were, you'll see that we have a name column and an age column. So it makes sense to have our ages be on the x-axis, our names to be on the x-axis, and our ages to go up like a classic bar chart. We could also flip it and have it be horizontal, but for now, let's put x equals name. Then we'll have our next parameter, so we put a comma between them, y equals, and we'll have it be age. We press play, and we immediately, how powerful was that? It just made a visualization for us. So now, why would we use Altair? As I said before, the Pandas excels in computational tasks, but its visualization API can be convoluted, and it's also limited. There's not as much you can do with it. So we're going to use API. We can use Altair because it's more comprehensive and just as powerful, and it brings Python to this idea of a visualization grammar that maybe that doesn't make sense right now, but it will make sense when we learn about encodings and mappings in right now. And it makes graphing a lot simpler. So let's add a bunch of code boxes. Let's graph the same plot with Altair. It'll look really similar, but we need to call the Altair library, which is alt dot, and we use chart parentheses, and Altair requires a Altair specific kind of data value. So we want to pass, so this is what alt.chart is making. It's making this Altair data type kind of thing. It's called the object. And we place into that the data frame is one thing that Altair will take. It will also take a URL. It will take a JSON value. And so here we go. People underscore df is our data frame. And we mark underscore bar. So this is saying we want to mark it as a bar chart, parentheses, dot encode, parentheses. And now we'll say what we want our x and y axis to be. So here again, we'll have x equals name, comma, and y equals age. We press play, and we get pretty much the same graph with different sizing. So we can now go in and let's talk a little bit more about what is happening. So we'll pretend like, for now, let's say that to graph in Altair, we have kind of 3 steps. We specify the data, which is this alt.chart, and with the passed in type, which for us was a data frame. We have what kind of mark we're doing. So it can be a bar. It can be, in future examples, we'll show lines and scatter plots. And we have the third thing is the encoding. And that's what we want on our X and our Y. And this is where the data goes. So again, we have the Altair, the data, we have the graph information, and then we have the data information. So now take a second to think about if we wanted to make the exact same chart, but green, where might we define the color? We'd write color equals green somewhere. Would we write it in somewhere in this making the data object? Would we write it in defining the graph? Or would we write it in defining the data? Okay, so because there's so many of us, I'm gonna go ahead and show what happens on both. So color equals quotation marks green is one option, and we can press play. Okay, cool, that worked. What would have happened if we put down here color equals green? It didn't work. It's specified without a type. What if we put color equals a kind of data? So let's say color equals age. Now we have this very interesting like ombre, there's like an ombre to the data. It goes darker and lighter. And what we're seeing is that the color is now mapped to the data. And that's what's so powerful about this encoding. We know now we can map things to data that isn't just the X and Y axis. And so you see the darkest color is because this John was 40 and the age was 40. And it automatically put this together for us. Okay, so the data we're going to be working with was going to be in a JSON format. And JSON format is basically a human readable, it's just a way of storing data. If you see it in Excel, you see it with is one way. It's like English versus Chinese versus just different formats of how you would do the same thing. And there's other kinds of formats. There's comma separated values called CSVs. You have space delimiter data, but we will use JSON data mostly because I like it, but also because it's a really common way of storing data. And it's available on New York City Open Data. If we wanted to turn our data that we have, this people data frame, into JSON, or then how would we want to do that? If we think about it, we had our data frame in this thing called a dictionary. And our dictionary is a lot like JSON. I want to show you what JSON looks like, but okay, I'll show you. We'll see what JSON looks like in 1 second, and then it'll be a little bit more clear. Here we go. Okay, I found some JSON for you. Okay, so here's some JSON that you can start seeing what it looks like. So we see it has these squiggly lines, just like it's like a list. We have the bracket, then we have the squiggly line, a lot like the dictionary, and then we have this value colon value, so the key value pair. So it really is just a lot like a dictionary. So let's turn our dictionary into JSON just so we can see why we learned about dictionaries. So we had that a_dictionary equals, and we already have it, so let's just print it out so we can remember what it is. Here we go. And we can convert it to JSON. So let's write import JSON. It's a library just that'll give us functionality to do this. And we press play. Great, we got our JSON. And let's write a_JSON. So let's make a new variable that equals holding all that JSON, holding all the data. So we'll say JSON, which is a library, dot dumps, parentheses, a_dictionary. And let's print out a_JSON. And it looks pretty much identical. But I'll show you something right here. If I put the type around this dictionary and I print it out, it says it's a dictionary. But if I put type around this a_JSON, it returns stir or string. And so they're very similar, but JSON is a string, and that looks a whole lot like a dictionary. Let's change our data frame and then see how it impacts JSON. So we have our people_df that has our name and our age column, and let's add some more data to it. So with the square brackets, we can say we want a new column, and what's the name of it? Let's say we're gonna put in its full name. So full name, it'll be the name of the column, and we're gonna assign to that column a value. If we put the string dog, everybody's full name would be the string dog. But let's say that Susan, Marciana, and John are all in the Johnson family. So we can say that people_df, and we're gonna get that first name, so that's the name, and we'll concatenate it, so that's the first name, and we'll concatenate it like we did with Hello World with a string, put a space first because we want a space between the first and last name, and we'll say Johnson. And then we'll print the people_df out again. And we press play. Now we see we have another added column to our data frame, and let's convert it to JSON to see how it changed our JSON. So we'll print parentheses people_df, that's our data frame, .to_JSON, parentheses. And this is how we can turn a data frame into a JSON object, which will be useful if you end up taking a data set or making a data set and wanting to share it with people in the future. So people_df to JSON, and if we look through it, we'll see that there's this name column, this age column, and this other full name column. So what if we can look at it in another way As well, we can write print people underscore df dot to underscore JSON parentheses, and this is the same line we had before, but inside we're going to give it an argument. We're going to say, do it a little bit differently. We're going to orient equals, so we're saying the orientation of our JSON is going to equal, we want to look at it by records. And this is a little more intuitive. If we look down now, we see we have the name Susan, age 20, full name Susan Johnson. Then next is Mark, 30, Mark Johnson. And this is a lot more human readable, at least for me. It's hard. This is columns and this is records. Okay, so now that we are familiar with this fake data set that we made, let's use some real data. And thank goodness we have New York City Open Data, because we're going to get some really cool water consumption data. Here is you don't need to open this link, but I'm just going to show you, this is where the data came from. This is the New York City Open Data website. This is the water consumption in New York City. We scroll down, we can learn about what's going to be in this data. Each row is water consumption by year. There's 4 columns. We can see that there's a year column, a New York City population column, a New York City consumption, and a per capita gallons per person per day. And here's some of the data you can start viewing. You can also see the type of the data. We have text, so like a string, number, so like an integer or a float, is like what we had in Python. So if we were to pull this data, how we do it, we click on API, and this is the API endpoint, and it's located in the browser. And I'm just gonna click copy, and I'll share what I copied in the chat, and you will want to copy it from the chat to continue on with this workshop. There are lots of ways to get data. I think this is really clean. I don't want to download it to my local computer because I don't want to take up my memory on my computer, or because I'm never going to remember to delete it later. So I like to pull it into the Google Colab notebook so it doesn't go onto my machine. But you can also just, if you're interested, you can always download the data directly. So I'm going to go back to the Collaboratory notebook we're working in, and let's add some more code boxes. So in a comment, just so I remember where I got that link so I don't have to go back and get it, I'm going to put the link. Oops. This is the JSON endpoint. And what does that JSON endpoint actually look like? So it's JSON. It's just a website that most people don't go to, and it's holding all this JSON data. So how are we going to get the data from this website? So we're going to query it. To do this, we are going to import this library called request. We're going to send a request to that site and say, I want to get your data. So import request, and let's save water underscore consumption underscore URL equals, and it's that endpoint I put in the chat that we just looked at, and we can press play. And so now I want to ask you, what is water consumption URL? It's a trick question. You might think it looks like, oh, this is like something fancy is happening here. It's really just a string. If we print it out, water underscore consumption underscore URL, this is just a string. We haven't done anything yet. We just saved the URL as a string. So now let's work with that string and the request library. We will write requests, which is the library that gives us the power to be able to do this easily, .get, so we're getting something, and we will pass in that water consumption URL. So the request library is going to go to that URL and get it stuff for us. Press play. We see response 200. In web talk, how the servers talk to each other out in the internet, 200 is a good thing. It means success. But we actually, when we ran this, the data, it got returned, but now we don't have it anymore. So we need to assign it to a variable, and we'll say response equals request.get water underscore URL. So now we have the response, and now we're going to convert that response to a JSON format. So we'll say water underscore consumption underscore data equals response dot JSON, because this is that response that was got with all of the data, the thing that said like it worked. And let's print out water consumption data. Press play. And here's all of our JSON. We just grabbed it and we put it in our notebook, super clean. Yep. Okay, let's add some more code. And now let's work with it. So first step is to find the data you want to work with and get it to where you need it. Second step is let's plot it. So just like how we did before, we use the Altair library, alt.chart, pass in that water consumption data. This is our first step, which is making the Altair data object, and this is our JSON data, dot mark underscore bar, quotation, swirly bracket, parentheses, dot encode, parentheses, x equals year. And now that we took the data from another site, if we didn't make it from a data frame, we need to tell the Altair what kind of data is in each column. So our year is, let's say it's an O, it's objective data. Quantitative would be Q, so Y equals per underscore. And look at this and see what maybe we want it to graph. So here we could say per capita gallons per person per day. Wow, it's so long. I'm gonna copy it, and you can paste it, and then you don't have to make any mistakes. And then we can put a Q, and think about it. Do you think this is gonna work? Okay, let's play. So it didn't. And let's look at what the error says. It says class list is not recognized. So why did it fail? So earlier we plotted the data directly by making the data frame. Well, we plotted the data frame, but Altair can recognize data frames, but it doesn't immediately recognize the raw JSON. So we need another step. And there's a couple different approaches. We could convert the JSON to a data frame, like we did last time. We could skip the data frame entirely, and we could say something like values equals JSON. But this time, just because data frames are really important, let's convert it to a data frame. So before this line of code, put some spaces, and we will say water underscore consumption underscore df, so data frame. So this is just me naming it, equals, so we're assigning that to be pandas dot data frame is how we convert to a data frame. And we pass in that JSON data, which is the water consumption data. So if you see, I get some of the variables start popping up when I'm writing them. If you click return or enter, it will select the highlighted terms. You don't have to fully write it out. And then now we would want to pass in not the JSON, but that data frame. Now if we press play, we get a graph of the New York City water consumption per gallons per person per day. So let's pretend like let's look at another column. And maybe this is a place that it's the first column you are actually interested in looking. And we can look at New York City consumption millions of gallons per day. So we can copy this column and we can get a completely different graph, which is why coding can be so powerful. We just come in and we can replace it. So New York City consumption, million gallons per day. We press play and we'll get a different graph. And so basically we're seeing this bar graph and we're looking at each year, and it's from 1979 to 2019. And bar charts are a really good place to start with data visualization when you're not sure what to do. But then, and it might be the right thing to stick with. It's a pretty safe chart. When we're looking at this time data though, you might notice that the bar chart makes you want to look at each year separately. And data visualizations are really good for showing patterns and trends in data. And with time data, it's pretty continuous. And so a line chart might actually be a better fit for this data. So let's try, we can just copy this chart and we'll paste it. And the only thing we need to change is the type of bar of the type of graph we said. So we said bar, and now we want a line. Press play, and now we have the graph with it being a line graph. And so something that's pretty cool is that data sets have data columns that can be useful in completely unrelated ideas. So you might think, I only want to look at the water data because if I'm interested in water. However, what if you're interested in something else, but you need New York City population? This data actually has a column for New York City population. So sometimes searching through maybe not seemingly related data can be where you can find the data that you want. So let's do another graph. We will say it'll be the same graph, so we can copy and paste it here. Again, and instead of New York City consumption million gallons per day, let's put in new underscore York underscore city underscore population and press play. And now we'll see. So here we see that water use was going down. And here we see that population was going up. What if we want to compare these two graphs? Like maybe we want to look at them on the same graph. We can do something called layering. And just like how we could add strings together, we can actually add graphs together. It's very flexible. And so in order to add graphs, we should save our graphs under variable names. So here we can go and save this one as water use equals, and then under here we have population equals, and we need to play them so that they actually get assigned. And you'll see that it doesn't print anymore because now there's not a value at the end, there's an assignment. If we wrote the name at the bottom, we would see it printed again. And so now we have a water use and population graph, and we can write water underscore use plus population, and we run it. And we'll see they are both there, but they're hard to see. We have one is way down here, and one is up here. And the one on the bottom looks just like a line. And what's happening is that the values for one of them is just way smaller than the values for the other. So if we could figure, there's not that much data, and it's pretty simple to go and look or to even guess. But we can use some of that encoding of an Altair, the coloring and styling to figure out which graph is which. So if we go back to our population, let's say it's a color. So color equals, and let's say it's black, and we press play. So now we see that this was the population graph. The population is way bigger than the water consumption. And it's New York City consumption in millions of gallons per day. So it's the water consumption divided by a million versus New York City population, period, that's it. There's no rate at which each is represented. So you might think as a first instinct that, okay, why don't we just bring the gallons of water to multiply it by a million and then plot it again. So let's see if it works. So let's add a new column to our data frame that is the water in gallons rather than one being a million. It'll be one gallon. So we'll have that water consumption df, which is our data frame, water consumption df, and we're going to add a new column, so square brackets, and we'll write New York City underscore consumption underscore gallons underscore per day, because the other one was million gallons per day, so this one's just gallons per day, equals, and we will say water underscore consumption underscore df square brackets, and we want New York City in here. We want the New York City underscore, what is right here, consumption million gallons per day, New York City underscore consumption underscore million underscore gallons underscore per underscore day, and we'll say times 1 million. I think that's 6 zeros. Okay, and then we press play, and let's print out water underscore consumption df, and you'll see that this looks really weird. This is not actually the number being multiplied. This is the number getting concatenated a million times. So it's a string. We were looking at a string that looked like a number. So we need to convert our string to a number before we multiply by a million. And also, I can't believe that loaded that fast. So that's, again, the power of coding. So we'll come back down and let's try again. We need to convert to a number first. Let's copy it because those names are so long to type out. And let's scroll back down and paste it in. And so we have this water consumption df, the water consumption gallons per day. So this is just what's getting assigned. And now we have, this is what is a string. So we need to convert it to a number. And Pandas has the functionality to do that. So we'll write Pandas. We're going to call up our tools, pd dot, and it's called to underscore numeric. We're turning it into a number, parentheses, And what's going into that is all the stuff inside the water consumption million gallons per day column. So all of those, what we see here, what were strings, are now going to get turned into numbers and then multiplied by 1,000,000 and stored in this column. So we press play, and now you can see the million concatenated of that number is now gone. We've replaced that column with a new column because we assigned it to the same column name. And we have it right here, New York City consumption gallons per day. And it's, again, this number times 1,000,000. So let's scroll down and let's try to graph it. So add some more code boxes. And okay, so now we're going to have, let's rewrite our population. So our population one is still the same. We didn't touch it. So we just need to update our water use graph. We had the alt.chart parentheses, and it took in the data frame we have, which is going to be, which will be the water consumption df dot, and we're gonna mark as a line, and we are going to encode the same way we did before, where we're gonna have the x-axis equal the year, and we had it, I believe, as an O, and we will have the y-axis equal the New York City, the new column we just wrote, which is right here, New York City consumption gallons per day. So we want to write that in. That's the new y column we want to look at. Let's just copy it, New York City consumption gallons per day, and we'll paste it in right here. And this is a quantitative data, so we want to say it's a Q. And we're going to store it as a variable so that we can add it to population. And we'll just call it, again, we're going to replace the water use data that we had before. Water use equals this. We press play, it compiled. And underneath here, let's write population plus water use. And press play. And now it's flipped. Remember, we had the black was the population on the top, and we couldn't see water. And now we can see water, but we can't see population. So the next thing you might think, okay, we can just change it again. We could change the numbers so they're more similar and can be graphed together. If we look at the data frame, so now let's actually analyze it. We have the population is in what reaches the single digit millions. We have consumption in millions of gallons per day was in the thousands. So we just really needed to add 3 more zeros if we wanted to see them next. So it would be multiplying by 1,000 rather than 1,000,000. So this is something you could do. The question is, should we be doing this? Does this make you feel uncomfortable? Just think about that. Does it feel weird to change your data just to keep manipulating it so that the lines start getting close together? Let's just try let's just do it and see what happens. So again, we'll go back up here where we made our new column, and let's add in, so this is New York City consumption gallons per day. So 1,000,000 divided by 1,000 is 1,000. So New York City consumption underscore 1,000 underscore gallons per day. And we're just gonna do it by 1,000 less, so we'll delete 3 zeros. And when we press play, we'll get another new column. And now you'll see this is in 1,512,000. So that should graph quite nicely next to the population, which is 7 million, and so still single digit millions. So here, let's make a new water use. So it's New York City consumption 1,000 underscore gallons per day. Press play, and we'll press play one more time. So now we can see them side by side. And so you can do it. The question is, should you do it? And that question, there's 2 reasons why it's probably not a good idea. One reason is the visual effects of sizing and scaling. You've probably heard, or maybe you haven't, about misleading graphs. And I'm gonna show you a copy link. Okay, so misleading graphs, for instance, here there looks to be so much, like a big difference between the bar A, B, C, D, and E. It seems, okay, wow, they're growing a lot over time. But if you look at that y-axis, the y-axis starts at 9,100, I think. I can't really see it, and then if you look over here, the y-axis starts at 0. And this is the same data, but on one, the difference between the data, each column seems to be very dramatic, and on the other, it seems like it doesn't really exist. They're basically the same, and that's the same data. So that's the effect of sizing and scaling. There's other things like the ratio of your graph dimensions. So here we have the original graph, then they have the width and twice the height, and now the rate of increase looks exceptionally steeper. And over here, they twice the width and half the height, and now the acceleration looks way less, like way decreased. And so there's lots of things that can create a misleading graph. People do it sometimes on purpose, and people do it oftentimes on accident. And the important thing to know when you're making graphs is that you should try to make them as accurate and not misleading as possible. And there's not a hard and fast rule but just really thinking about who is looking at it and how a human might look at this and be able to infer the meaning that you're coming from, and if that accurately is shown in the data. So here it's really hard for somebody to look at this graph and to imagine in their heads that this one is 1 to 1 and this one's divided by 1,000. That's very difficult to do. It's also hard to even look at both of these lines and determine a relationship. What is more effective would be to show both of these lines in one value, a ratio of the gallons of water use to population. So what we're going to do is, you could make a ratio, but actually this is something that New York City Open Data, whoever made this data set, was expecting. And there's a column that is a ratio. And that column is, is New York City capita gallons per person per day. And so let's graph the ratio. So to graph the ratio, we are going to write the same process we did before, alt.chart, parentheses, take in our water consumption data frame. We're going to mark it as a line, chart, dot encode x equals year, put it as a O for now, and y is going to equal that per underscore capita underscore gallons underscore per underscore person underscore per underscore day Q. And then we'll chart that. Oops. And it says that, oh, sorry, I must have put a 0. Sometimes I do that. There we go. It's O. And now we have this. This is much easier to read, but let's try to improve this graph. So this is definitely the way we want to represent this data. And let's look at what it looks like. So let's copy it and paste, and we can do it as a scatter, just to see what it looks like. So I'm a big fan of putting scatter plots on top of line plots, because I think it shows, whereas in the line, the data points could really be anywhere. It shows how much data is actually in the line graph and how much is the connection between each point. So we're gonna layer both of these charts. So the first step is to assign the line and the scatter plot to variables. So we can say water underscore, we'll name it water underscore line equals this one. And we will say water underscore point equals this one. And then we can add water underscore line plus water underscore point. And now you'll see they're quite nicely mapped. We have the scatter plot on top of the line plot. But there's still some work to do. We can make this graph really nice now that we worked so hard to figure out what data we wanted to use. Let's make a beautiful graph. So let's get into styling. In data viz, again, what it is, it's communicating to people. And so just like in web design, how you need to really think about your style choices, in data viz, you need to do the same thing. You want it to be appealing, so you'll want to mix serif fonts with sans serif. If you get into wanting to do it like that, you want to make it accessible. And you want to make it accessible, so you want to maybe not use as much color, or make sure that the graph can be read without the color. So if somebody can't see the color, or that they can still understand the graph. You want to have high contrasting colors. You can even use visually, you can use colors that are easier for people to see, and all sorts of things like that. Okay, so I want you to take a moment just to think about the different things in this graph that you'd want to style. Okay, and so some of the things you might want to style would be the color. You might want to make the points pop out more. You might want to change the axes labels or the title, and those are some of the things you might want to change. Okay, great. So let's go ahead and do some of that. What we'll look at first is, let's look at this water scatter, or the water point chart. And let's change the points to be a different color so they stand out more. Here, let's write that, so this, where the chart is maybe not where we want to write our color, because again, that is where the data object comes. So where we had the color before, we'll put it in where the graph is defined. So color equal, and we can say it's dark blue. There's a different Altair colors that you can use, and press play. And now we have this dark blue plots, but they still don't stand out much from the line. So let's make the line color chart lighter. So color equals light blue, and press play. And now we have this really beautiful dark blue plots on top of a light blue line. But maybe the points are just too big for you, or you want them to just be a different size, whether it's bigger or smaller. So you can come in with a size equals, and its standard starts off at a font size of 30. So I'm going to make it smaller, font size of 20. If maybe you want to make it bigger, whatever size you can pick. Press play, and now the points are smaller. And there's lots of different things you can do when you're styling your graph. You can change the shapes instead of circles, you can make them squares or triangles or diamonds. You can use you can make the line a dashed line. And it's just as easy as you see here, where I'll be changing the size and changing the color. All the styling tools are really available for you, and at least for defining the visual of the graph. So now, something really important that's missing from the graph is a title and axes titles that are clean and look just a lot better. So let's go ahead and label our graph. So to label our graph, we can just go into one of the graphs and put a comma. So this is our data object, and our data object is where our title is going to come in, because it's part of the Altair object is this title. So title equals, and I'll name it New York City water use from 1980 to 2019. If anyone's looking at the key, I think it might say 2020, but that is not correct. So you want to change, but it's 2019, press play. And we got a title. But we want to update the axis titles as well. So the axis titles, again, the axis, the X and Y was associated in the encodings of the data. And we'll need to place our title in our axis labels in there. So to do this, we are going to say X equals and alt, which is the Altair library. We're calling a new functionality, which is associating with this X, which is just how they've called the X axis, parentheses, and we'll rewrite this inside. So we'll have year, and we're going to change it to T because it's a time instead of a O, or N, which is nominal. That's like qualitative data. Q is quantitative, T is time. So year, T, and we'll have axis equals Altair library dot axis, parentheses, and inside there, we're going to assign our title equals, and I'm just going to make it a capital year instead of a lowercase. And if we press play, we need a comma after this one, just like we had before. Press play, and then press play again. And now year has been changed. And we can go ahead and just think for a second about how you might want to do that for the y-axis. And I'm going to say you were right. So altair.y, parentheses, and we're going to have we just match it. So year and T, and here's our data, comma, axis, axis equals alt dot capital A axis parentheses title equals, and then you give it your title. I'm gonna just get rid of all these underlines and make it capital. So per capita gallons per person per day. And if you notice here, we have two parentheses, so we're missing a parentheses. And you can see that it found it by, you'll see these little highlights. So that's a little trick you can use to make sure everything's in order. Press play and press play. And now we have a pretty nice graph, I think. Oh, except for the time data that got really weird. So maybe we don't want it to be a T, we can leave it as a, yeah, X equals year. What happened? Oh, here we go. This one, T. So you can see how these encodings interpret the different data in different ways. We want this one to be an and this one to be an O, and then we can add them. And now we're back to our nice years that we had before. Other time, so time, there's different ways of showing time. You can show it as like day, year, day, month, year, or seconds and stuff. And in this case, having the year shown as a like qualitative, just like objective, the O type worked a lot more clearly. Now, what can we do with this visualization? What can we use it for? If I'm making a web page, like I didn't make it out of Python, well, you might have made it out of Python, but you probably didn't. So I'm gonna do this thing. It's called inspecting my web page. It'll take a second because my browser's really slow. And I'm just looking at, so it looks so weird. Okay, oh, here we go. It works now. It's been lagging a lot. So I'm inspecting a web page, and this is just like my browser. And I see all this code after I press Command-Shift-C on my computer. And this is all HTML code. It's like the web language. And you see these square braces and a lot of like key, and so it might look really weird, but this is, as I'm moving around, it'll highlight different parts of my web page. And that's just how the language that is making our web pages. Let's see how Altair can interface with that. So we can say that we have this graph waterline plus water point, and let's just assign it to a variable name. So we'll just say like our first data viz equals water line plus water point. This is an underline here. Okay. And now we can save it. So let's write whatever you named it. So I named mine our first data viz dot save parentheses. And I'm going to save it, and as I'm going to name what it's going to be saved as, like the name that if you downloaded it, it would be on your computer. And I'm just going to make it a little bit more descriptive because I will lose it. So New York City underscore water underscore use underscore 1980 underscore 2 underscore 2020 dot, and I'm going to have it as an HTML, which is what I just showed you, all that HTML code. There was some other stuff in there, like some styling, which used CSS, but it's mostly HTML. And when I press play, you're like, nothing happened. But if we click this file button over here, we'll see that the file has now been downloaded. It's been saved. So I double click, pops open, and it looks just like all that crazy stuff that was the browser web page. It's HTML, and you can see that it basically has created this HTML out of what we made with Altair. And if you scroll through, we can see all the styling we had. It looks a lot like JSON. You can see we have the dark blue, and here's the encodings, and then all of our data. It just goes on, and it's all of the data. So that's pretty cool. Now we have it just automatically converted to HTML, but why is this useful? So you could hover over this and just save it as an SVG or a PNG as a picture, but you could also click over here and download it. And then I double click on New York City water use, and now I have this popped up in my browser. So you could put this, because it's an HTML, it's able to be rendered on the browser. And this is when I double clicked, it rendered the HTML in my browser, and it made our graph. And so this is a really nice charting tool if you want to put data visualizations into web pages. Okay, so let's continue. So we're going to start working with a different data set. We're going to work with the waste management main sort. You can learn a lot about a person by their trash. And so we're going to learn a lot about people in New York City. And so the New York City main sort I'm gonna open it up to show you. Okay, so this is our the New York City Open Data page where I got the trash data, and you can read about it. So I guess we're looking at 2017 data, and they basically sorted trash into 70 categories, and they sub-sorted an additional 172 categories. So what does that mean? Let's scroll down and we'll see that there's this column called material. You can see all the materials in the waste stream. And if you hover, you can see a bit more. You get aggregate percent, the percentage of a material in all combined waste streams, the percent that ended up in the trash bin, the percent that ended up in the metal, glass, plastic stream. This is like the paper recyclable trashes, the organic trashes, and the material group. And there's a lot of locations. There's a paper also here if you're interested in reading a bit more about how the data was collected. I'll throw the PDF of the study into the chat. Also, I apologize that I haven't answered any questions. I will look at them at the end, and I'm happy to answer questions after the workshop. I just have a lot of material to get through, and I was nervous about having a lot of people in the workshop. So here's the PDF, and that's, if you probably not right now to read through unless that's of more interest, but it's really interesting. You'll see even pictures of people just sorting the trash, and it's really cool how they came together to put that data set. So we're going to look at it and we'll learn a bit more about it as we go. So just like before, let's grab our data from the endpoint. So we click endpoint. We're going to take it in a JSON format. I'm going to click copy, and I'm going to give it to you in the chat, and then we'll go and we'll grab it. So again, we have that requests library. We already imported it, so we don't need to import it again. But if you did, again, it would just be import request. It would look like, without the hashtag, it would be like this. But actually, if you do it again, nothing bad happens. It just runs again. And so waste underscore, so we're just gonna grab the URL and as a string, just to store it in a variable. So waste underscore management underscore URL equals, and then we can just paste the endpoint that I put into the chat, this JSON endpoint. Actually, this is fun. I'm going to show you what it looks like. It's huge. There's so much more than the last time. The water consumption data was actually a really small data set. Yeah, so here we are. We have the string. Press play, and let's get it. So we're going to use the response is going to equal requests.get, so we're getting it from that web page. It's that waste management URL we just defined. We could also have just passed in the string directly right here, but we just stored it in a variable first because it looks really clean. And then waste underscore management JSON. So this is what we want to get. So we're going to want to get a waste management JSON variable holding all the JSON. And how we're going to do that is we're going to assign it from the response we got. Oops, I misspelled response. Response we're going to get, and so response.json. We get the response and we we want the JSON, get it the JSON. And we press play, and then we can just print out the waste management JSON. And here we go. We got all that data, came so fast, all that data. And we can start peeking at it. We see aggregate percent, the DSNY diversion summary, it's electronic waste, how much, we just see all of these things. It's not necessarily like very readable yet. So let's put it into let's either plot it or inspect it as a data frame. Okay, if you remember before, we had issues that we needed to convert our JSON to a different type before using Altair. We converted it to a data frame. This time I'm going to show you how you can just use the JSON straight. So we can say waste underscore data, just to save it, equals alt.data. So this is making our Altair object, Altair, and we just say values equals, and it's our waste management JSON. So that's what we had before, and we're just saying the values is going to equal the JSON. And if we print waste underscore data, you can see that it's this is what the Altair data type looks like. It's a data, and it has a values, which is a key, pointing, it's getting mapped to the JSON. So the values are the JSON. Okay, so now that we have that, let's plot it. Alt.chart, parentheses, and we want to get our first step is we want our data. So we're going to pass in that waste data, just Altair data type. And we're going to mark, and we have to decide what kind of chart we want to do. Let's just do a bar, because at first it's a pretty safe one to start with. And we're going to encode, and we need to choose something for our X and our Y axis. If you remember when we were looking at, so we have this material, we have material groups, these are like qualitative, they're like they're like words, and then we have percents, and those are like quantitative. So let's choose a qualitative and a quantitative. Let's say the X equals the material group, and we'll call it an O type. And then we'll have the Y equals aggregate underscore percent of a quantitative type. And we can just print this. And now we have a bar chart. And when you look at it, you might start thinking, okay, so at least when I look at it, I think, okay, so this is like the aggregate, maybe percent of all the data for organic. Basically, the percent it had was almost approaching 30%. But if we actually inspect this, we can use that styling we had before, and we can use this one called opacity. And that's like the see-throughness of like how sheer we let our bar chart be. And let's say it's 0.3. We print it, and now we see that it's much darker on the bottom, and it's like see-through on the top. And what's happening is that there's data being layered. So in fact, it's not an aggregate, it's just everything being plotted, and a lot more happened to be lower. So that opacity was really useful to see that maybe we might have misunderstood what we were plotting. Now let's explore this a little bit more. So let's just copy this, and let's change it to a scatter plot. We'll get rid of the opacity, and instead of a bar, let's make it a point. And now we'll see exactly what we've inferred before with the opacity, which is it was an aggregate. There's tons and tons of points, but we're exploring, and we're like, what do these points stand for in the data? So there's a tool that is really honest. It's such a tool. It's called Tooltip, and it's actually named to be a tool. And it can help us explore what's inside our data. So let's go, and so we have the X, we have the Y, and we're gonna have a tooltip. And we're gonna equal material, so we can see like what kind of material it is, and that's a nominal data type. We press play, and it looks the same, but when you hover over it, each point now, it'll pop up what the material is. So we see food, yard waste, and you're like, why are there so many materials that are why is the same material occurring multiple times? Well, we put in location, so it's okay, location, then when we hover over, we get undefined. And why is it undefined? If you look closely at the data set, location is spelled incorrectly. So it's actually location. And if we press play, now when we hover, we get the location of each data, the location. And so we see schools, and that was food. And we see New York City Housing Authority, which was food. And so what's happening is each location in the data and for each material is being plotted. So it feels like there's a lot of repeats. And when you're looking at this, it's, geez, where do we go from here? This is a mess. Actually, let's flip it on its side and see if it looks like anything familiar. So to flip it to be horizontal, we're just gonna take the same chart, and let's just change our X to a Y, and our, not a yield, X to a Y, and our Y to an X, and we press play. And now, does it look like anything familiar now? It looks like a bar chart, like a mouse plot, like a mouse and whiskers plot. We still have the same issues with repeats, but we can see what graph might be interesting. So let's just start off by turning it into a box plot. So we can copy and paste, and instead of a point, we'll use box plot, and we print. And now we have this box plot. If you're unfamiliar with the box plot, it basically shows distribution. if we even on hover, you can see it's like the quartiles. You have the median, you have the lower quartile, the upper just like it splits it into a couple pieces. So and that's what each of these lines are referring to. And then these points you see are outliers. They're values that were so much greater or so much less than the median or the quartiles that they actually just don't fall within the data, and they're considered outliers. And that's quite interesting in trash, because it's not like anything happened random. It's like there's just some material that there's a lot of, or maybe it's if it's maybe a location, it's just some location has the most trash. So outliers are quite interesting when you're thinking about trash, if you were trying to figure out where you wanted to tackle plastic waste or something of that matter. So here we can see that in paper, for all the data, schools are an outlier. Schools use the most or have the most paper in their aggregate percent of trash. Schools were also had the most, what is this, organic waste? And if you change it to material, you can see what those things were. And we can look here, and now we see that schools had a lot of compostable soiled waxed OCC craft paper, and schools had a ton of food in their trash as a percentage of what is in their trash. So this isn't maybe a graph that we'd want to publish or anything, but it's a good starting point for exploring our data. What we'd want to do next is maybe filter out what data we're looking at in this box plot. Maybe we want to look at one material or one location, or just get less there. And what we'll need to do is we're going to need to work with our data frames. And so we're going to need a data frame. Before we skipped making a data frame, because we made our Altair object by passing in the JSON. So now we're going to make a data frame again. So we're going to make a waste_df, is what we're going to call it, equals pandas dot, you're an expert at this one, data frame, parentheses, and inside there, we're going to pass in the JSON, which was a waste management JSON. And then we can print it out just so we can make sure it looks good. So now we have a list of material. This is so much easier to read. We see locations, we have citywide, New York City Housing Authority. We have the material groups, special waste, paper, miscellaneous, and organics, and all these percents. What we're gonna do first is let's update the location spelling, because then we don't have to write location every time we want to use location. This would have also been really useful with the other data set, because their names were super long and you had to write them every time. So we're going to redo our waste. We're going to assign to our waste data frame an updated version. So waste_df dot rename parentheses, and in there we're going to write columns equals, and it's like a dictionary. It's a key value pair, and we're saying that what is it currently called? It's called location. What do we want it to be called? Location. And then let's print it out. There needs to be assignment operator equals. And now we go down, location is now correctly spelled as location. So now let's continue on. Now let's filter our data to maybe look just at citywide data. So we can see the distribution citywide of maybe material group, how material groups are used, maybe material outliers on a citywide basis. We're going to filter that data frame. So we're going to have that waste_df that we just got. And to filter, we use this thing called loc. And it's like locating where, and then inside of here, we're locating where this column, where these values in our data frame column equal citywide. So we're just trying to isolate all of our data so that we only have the citywide data, which means, and to know if it's citywide, it's in location. And it means that if it's not, it doesn't equal citywide. So we're gonna grab the location column from our data frame, which is waste_df, and you get the column in it, and it's location. And it needs to, we're finding it when it's equal to citywide, that's when we want it. So equals was equivalence we learned before, and it should equal citywide. And then if we press play, we'll see over here, now we have only the citywide location data. However, if we run waste_df again, we didn't save it, it would disappear. So let's save this as a new data frame so that we can work with it. And we'll call it citywide_df equals. And then we can print it out just to make sure everything Nice. And now we have this new data frame that stores just the citywide data. And now let's make our box and whisker or mouse plot, whatever you like to call it, with this new data. So again, it was we first do the alt.chart, pass in our data. Now it's citywide underscore data frame dot mark underscore box plot, the type of chart we want to do, and we encode. And for the encoding, we had the x equaled the aggregate percent because we wanted it to be horizontal, and it was a quantitative. And we have y equals our material underscore group, and that we put as an O type. And we have our tooltip equals, and it's our material, and I put it as n just for fun. And then press play. And so now this is our citywide distribution. So we can see citywide, we can see the different values associated with the box plot. We have a maximum of 0.087, which is 8.7% of the trash was plastic, a median of 1.9% of paper. And so stuff like that, you can get some cool data, and you can compare the material groups. And you can also see this outlier, which is citywide. Food is a major outlier it's by far the greatest waste. And let's label our graph. And if we remember, we come in here and we say title equals, and then I'm going to name it New York City citywide trash representation, and we press play, and now we have a title. And then let's change our axes names just to practice. So x equals alt.x parentheses, and all of this goes inside the parentheses, and then we put a comma, and we say axis equals Altair.axis parentheses. And this isn't necessarily something you need to understand, it's just something you need to be able to reproduce. Title equals, and then you just give it a title. And this is the x-axis, so I'm just gonna make it capital, aggregate percent. And then we can do the same for the y. Alt.y, material group, axis equals alt.axis, parentheses, title equals, and material group. And then we need one more parentheses and a comma. Okay, and the other thing is, even though it's titled, you'd have to change the title, but you can look at other things really easily. You can have a nice graph of saying, I want to look at the percent of these materials that end up in the paper bin. And now it's mostly paper. And then there's some plastic ends up there, organics, and this is on a citywide basis. You can look at the MGP, and now you can see last is really in there, but something that maybe shouldn't be in there is food. And it's pretty cool. You can switch it around for the city. And now this time, so now we've looked at just citywide. So what happens if we wanted to, there's like a lot of different ways to have our box plot that we could have cleaned it up. Another way could have been to look at the materials rather than the material groups. And then we wouldn't have had a bunch of repeats. So let's create another chart, alt.chart, parentheses, take in our waste underscore data, dot mark underscore box plot, parentheses, encode, parentheses. And this time, let's say x equals, again, we'll just put aggregate, did I spell it right? Yeah, percent q. And then this time, let's say the y equals, it'll be material rather than material group, and it'll be a nominal kind of data. And the tooltip will equal the location. So press play. And how I figured out to do that was because we had a lot of repeats of materials in each column because of location. So if we separated it, then we would have a distribution for each material based off location. So here we can see the outlier. Oh, okay. So here we can see, we can see that we have a lot of data, and you can see the distribution based off location. Okay, so now, but the thing is, it's just way too much data to look at. It's not really effective. So we can practice our filtering again. And this time we'll filter and get just the plastic materials. We're going to take our waste underscore df, and we're going to use the location to filter again. And we're going to take in the waste df and based off the material group. So we're saying waste df locate when waste df of the material group is equivalent to plastic. So if it's equivalent to plastic, we want it, and we will type, so then we can press play. And now we'll see that our data frame now includes only entries that have the material group that belongs into, that's plastic, and we can save it. So plastic equals the variable, okay. And then say we're going to want to graph this now, well, we have an issue that we're doing location, and we have both a location, all of the locations, and we have a citywide location. So the citywide is just another average that's just existing inside the data. So we need to get rid of citywide. So now we have this plastic data frame called plastic, and we need to filter it to get rid of citywide. To do that, instead of using waste.df this time, we're going to filter it again, and that's the plastic.loc. And inside of there, we want to filter where the plastic doesn't equal citywide. So we'll have plastic, square brackets, and this will be where location doesn't equal citywide. Okay. And so now we'll see that citywide disappeared. It was the first thing up here, and now all the materials are plastic, and citywide doesn't show up. So now we're gonna graph this. So let's save it. So we'll name this one as plastic underscore minus CW minus citywide, and we'll graph that data frame. So I think what you're really seeing is how important the Pandas working with DataFrames connects with creating the data visualizations. So it's a two-part piece. So let's graph it. So alt.chart, and it'll be plastic minus CW dot mark underscore box plot parentheses and code parentheses, and we'll want to use all the same stuff we had in here. So we can just grab it, copy it, scroll down, paste it. I'm going to change this one to L. Okay, and it should say alt.chart right here, and this T popped in there from nowhere. Okay, so now we have the locations. When you hover, we see that of garbage bags, there's a lot of them in the trash, of the aggregate trash, and schools, percentage-wise, it's a huge part of their trash. With bottles, we see that that's super prevalent in the New York City Housing Authority trashes. And again, you can swap it to look at like the paper trash, how much of this plastic material ends up in the paper bins, and maybe this could be something you use to choose what kind of signs you want to put next to trash bins to tell people how to more correctly. For instance, looking at this, it seems pretty apparent you'd want to have a don't put garbage bags in the paper bin. So I realize we're out of time pretty much. I will now share my screen of I'll just go through some of the other things instead of doing it together, I'll just demonstrate some of the other things that we would have gone through if we had more time. So some of the other functionality you can use in Altair is you can actually, so with this box plot, we can use that styling tool, like we had the color, and we can use like an if-else statement to determine which to highlight. And this is like encoding to data, but instead of it being like they figure out how to do it, we can just define it. So here we can say if it's organic, then make it black, otherwise make it light gray. Or here we can say if it's a paper, plastic, glass, or metal, so if it's recyclable, make it black, otherwise make it gray. So that can be good for communicating. So there's other kinds of bar charts you can make really easily. Here is a stacked bar chart, and you can see it's aggregating. So you can, but then when you're looking at this, you might think, oh, but it's hard to compare each section to each other. So you can make a layered bar chart. But as you can see here, it doesn't work when you have lots of things you want to layer. It gets really muddy. It can be quite nice if you have a few things to compare. Like here, we can compare locations with that same style of layer, of using the layered bar chart, and just to compare Brooklyn and Manhattan. And this is them being compared for plastic. Again, you can change it to look at any other materials or any other locations. And then here's a little mini case study of if we were interested in visualizing recycling accuracy, we could plot all the material, and we could plot the MGP percent. But it's still really hard to look at, particularly the ups and downs. So you might want to sort your bar graph. And you can do so with a functionality called sort. And we're sorting, decreasing on the y-axis, which is the percent. And now you see it gets nice and sorted. But the colors, it's hard to see what is something that was correctly recycled versus something that wasn't. So you can use that color coding of data that I showed you before in this kind of graph. And you can define that if it's a kind of material that was not supposed to be there, it's red. And if it's a kind of material that was supposed to be there, it's green. And you can just, it's so easy to change between the schools, the location, or the kind of recycling. And ultimately, maybe you wanted to have an interactive chart. So the last thing I want to talk to you a little bit about really quickly is that you can make charts in Altair interactive very simply. You can, so for instance, just with the word like dot interactive, you can change the scales. But what's most interesting, I think, is the ability to put in a selection. And we can select based on location, and it comes in and we get the selection bar, and we can say we want citywide, and now we have citywide data. We can get schools data, and it'll change for us. And then you can add everything together. We change the colors, so it's red and green, but the background with white looks really bad. You can also change your backgrounds. And then you add in your axes and your titles, and it's just a process, and you can get some really nice, cool, and interactive graphs in Altair. So we learned a lot today, and that's all I'm going to present to you. You can unmute yourself now if you have any questions. I will answer them at this point. Thank you so much for joining, and I hope that even if it was confusing, that this is just that you continue on your coding journey, because this is just the very first step. We ended up, it is recording. Maybe we'll share it. I will put together a completed, we sent the key, but it didn't have explanations. I'll put in explanations so you can follow through the workshop again on your own time. And particularly the section we didn't have time to get to, you can go through that and learn about how to make your graphs interactive. And I'll just share it with anyone who signed up. Okay, I'm gonna end the meeting now. And Linda, I don't know what Sparkle is. I'm sorry. I have not used it. Okay, bye. Thanks so much for joining.